everyone. Today I will be talking about Lamport's vector clock. To overcome the limitations faced by Lamport's logical clock, Lamport's vector clock was introduced. Just like Lamport's logical clock, Lamport's vector clock is also used in distributed system to determine whether pairs of events are causally related or not. But unlike Lamport's logical clocks, where timestamp values are given by the user, in Lamport's vector clock, the timestamp value for each event is generated in the system, and their causal relationship is determined by comparing these timestamps. Today's program, I will be showing how to implement Lamport's vector clock in C. So this is the problem statement. We have three processes, P1, P2, P3, having 3, 4 and 3 events in each of the processes respectively. So this numbers, it defines that event 1 of process 1 is 1, and this says event 2 of process 2 is 0. This says event 3 of process 3 is 0. Similarly here, this says event 2 of process 1 is 2, event 2 of process 2 is 0, and event 3 of process 3 is 0 as well. So that is how these numbers can be interpreted. In my program logic, instead of placing 1 and 0 and 0 in arrays, for which you will need pointers and dynamic arrays, I have implemented it using using numbers. I have depicted this problem statement using numbers. So how I would solve, how the problem here is solved, goes in this manner. So process event 2 of process 1 and event 2 of process 2 are causally related, and to update values, you compare these values 2, 0, 0 is compared with 0, 1, 0. With that, we see that 2 is greater than 0, so I update the 2 value here. 1 is greater than 0, but 1 is definitely lesser than 2, so you don't get the 1 value updated here. So the updated value for E2 of P2 is 2, 2, 0, and then this value gets updated in the consecutive events. So this 2 is updated here, 2, 3, 0, 2, 4, 0. The same goes with all the other causally related events. As for the way these numbers, the causally related events are numbered, it's same as the concept followed in logical clock that I've implemented in C again. So that's the problem concept. And another thing regarding how I've implemented is, yes, since I said that I have used mathematical logic to instead of arrays, here is how it is done. So I have created a matrix where I have mentioned the maximum event in this entire problem, that is 4. So I give 4 events, and that is represented as M, and process is represented as N, and there are 3 processes in our problem statement. And here 1, 0, 0 is just given as the number 100, and similarly 2, 0, 0 is given as 200 and 300, and 0, 1, 0 is simply written as 10, 20, 30, 40, and this is represented as 1, 2, and 3. From this, we can make the following observation. You see E1 1, this is E1 1, this is given as 100. This can be written as 1 into 10 to the power 2, which can be written as 1 into 10 to the power n minus 1, where n is the total number of processes. So 10 to the power 3 minus 1 is 10 to the power 2. Similarly, I can say the same for E to the power e to 1 equals 10, which is equal to 1 into 10 to the power 1, which is 1 into 10 to the power n minus 2. So these numbers 1, 2 and 3, they can be written as k, where k is equal to n minus I and I is less than or equal to n. So with that logic, I will be able to fill this matrix table. The second logic is in writing the casually related events. So the user makes the logic of writing the casually related events. So the user decides that the first event that is supposed to occur after E11 is E12. So this will be the second event that happens, the first casually related event that happens in the system, and this will be the second one that gets executed, and this is the third one. So accordingly we give the input for our casually related event. So C11 is 0, and as mentioned before, C12 is casually related to C22. So that will be written as 2, 3. So we start with 2, 3. So that will be the first casually related event. A relates to B. And then we have the second casually related event here. This is C32 is casually related to C23. So C that's given here. C32 is casually related to C23. So how I get the number 6 is that from here I add 4, and that is 6. So casually related event to C32 is C23. So I give 6 plus 1, that is 7. This is how I write my casually. So next casually related event will be 4 times more than this number, the number A. So that will be 6 plus 4, 10. So this is the next casually related event which gets the value 10, and the event that it is casually related to gets one number more than this. So that will be 10, 11. This is how you write the casually related events. This is the concept that I have used to write in my program. Now to compare the events of processes, comparing 2, 0, 0 with 0, 1, 0 to get this right value. How is it done mathematically? I have used this concept. So I have taken the example of E of 2, 4 and E of 1, 2, which is casually related. That is E of 2, 4 and E of yes, this one, it's E of 2, 4 and 1, 2. 4 and 1, yeah. So E of 1, 3 and E of 2, 4 are casually related, for which reason I'll have to compare E of 2, 4 with E of 1, 2 and see the maximum values that I get from these two and add it here if the previous value is greater than the value which is present here. So that is done in this way. I'm supposed to compare this value 242 with 200. This is the comparison that I must make, and to get the greatest value. So the value that I must get out of the comparison that I make here is 4 and 2. 2 and 2 is big, but 2 is not bigger than 3, so 3 is the answer here. And 0 and 4, maximum of 0 and 4 is 4. So the 0 here is smaller than the 4, that is the result I get in the previous case. So this will become 4. And here again in the third place I have 2 and 0. Maximum of 2 and 0 is 2, and that 2 is greater than the 0 in the third place here. So it will be 3, 4, 2, which is the answer, and in the program you will get it as 342. How is it done mathematically? First you consider 10 to the power n plus 1. So it is 242 modulo 10 to the power n plus 1, which gives me 242. Why have I done that? I masked the first three numbers to get the complete result here, and the result that I get here, I am going to divide it with 10 to the power n plus 1 minus 1, so it is 10 to the power 3. When I divide it, I get an answer here, 0. So the maximum, and the same thing I do with the second number, 200. So I get the answer as 0. Maximum of 0 and 0 is 0. In step 2, I decrement this value. Earlier it was 3 plus 1. When I decrement 4, I have 3. I do the same modulo operation, 242 modulo 10 cube, that is 242. And then I divide this number that I have got with 10 to the power 3 minus 1, which is 10 square, which gives me 42. And then which gives me 2. When I divide, I get 2. So this 2 value which I got is this number, the first number of 242. Similarly, I get the first number of 200 here. So I am basically comparing this 2 and this 2 here in the hundreds place. Maximum of 2 and 2 is 2. Now I decrement the value again. I perform the modulo operation and then I find the quotient. In this case, I'll be comparing the second digit of my 3-digit number, that is 4. So I'm comparing the 4 with 0 and the maximum is 4. Similarly, I decrement the value and now the result that I get compares the digits in the ones place of 242 and 200, that is 2 and 0, which gives me 2. This is how the comparison is done. This is what I have basically done in my program too. So this is my program. I've used math.h library because I am using the power function. This is where I've initialized all my variables. I have declared the number of processes that I need and the number of events in each process in the next one. Coming down, here I have down here, yes, here in this block, here in this particular block I have mentioned, I have filled my matrix table, and here I have mentioned my casually related events the way I spoke of before. Here is where I'll be giving the casually related events as my input, and this is more or less like the Lamport's logical clock, with the exception that I will be selecting the least value first. So that is why I'll be using this one parameter here, which is absent in the Lamport's logical clock. I'm using temp equals value, so I'm using that because you are supposed to find the lowest number. So 2 is the first number. This is the first this is the first casually related event that must get executed, and then this must get executed, and then this must get executed, for which reason I'll be using this parameter, temp equals value, where the value starts with 2 and temp is the number of my casually related events. Here is where I perform my modulo operation for the sake of comparison. These are the two modulo operations I perform, and this is the division operation I perform on the two values that I am comparing. And this is where I add it to my result. and this is for B related to A. The previous one is when A is causally related to B, and this is when B is causally related to A. The same thing happens here in vice versa. In the end, the result gets printed. So executing this will look like this. Entering the number of processes, that's 3. For process 1, the number of events that there is 3, and here we have 1, 2, 3, 4 and 3. So we give 3, 4, 3. And for causally related events, we have 0, 2, 11, 0, 3, 7, 10, 0, 6, 0. 0, 2, 11, and then we have 0, 3, 7, 10, 0, 3, 7, 10, 0, 6, 0. This gives the following answer, which we will compare. So the E11 must be 100, which is 100 here. E12 is 200, which is 200 here. E13 is 342, which is 342 here, and there is no E14, which is why it's showing 0. E21 is 10, 010, which is being shown as 10. And then we have E22. E22 is 220, E23 is 232, and E24 is 242. E31 is 1, E32 is 2, and E33 is 3. So that is the output that you get. That's all for Lamport's vector clock. Thank you.